right, welcome. So today we're going to be watching two different videos to cover our lesson. So we're going to start with a video on end behavior, which is on page A15 in your workbook. So what you'll see in this video is just the screen, my screen that I would normally be projecting in class. You'll see me writing on that screen. So it's essentially what you would see projected in class. I'll be bouncing back and forth between this and a graphing calculator today. We have, like I said, two different videos to watch. So we're going to start this first video on end behavior. End behavior is essentially what's happening on the ends of the graph. So what you'll see here is we have a function. This is a cubic function, x to the third minus 2x minus 1, and we're going to graph that. Now, we're just really going to sketch it. It doesn't need to be a super precise graph. So let's jump over to Desmos, and we'll enter that in. And you can enter it in along with me, or you can watch and use kind of my graph, x to the third minus 2x minus 1. And so you can see our graph. Zoom in just a little bit. And what we're really concerned about is what's happening on the end. So let's go back and do a quick sketch of that. Right, so that's certainly not a perfect representation of this graph, but it's a nice little sketch. All right, so this notation right here says on the right. It's another way of writing on the right. Technically, it reads as x, let me make a little arrow here, as x approaches infinity. But that's really saying on the right. So on the right, what's happening with y? So if we follow the graph all the way to the right end, we have three options. The graph's either rising, falling, or flattening off. And in this case, the graph is rising. So we say y approaches infinity. Or in words, on the right, the graph rises. Next, we have this notation right here as x approaches negative infinity. And what that reads is on the left. So on the left, if we follow our graph to the left end, it's either rising, falling, or flattening off. And here we are falling. And so we say that it's dropping to negative infinity. So on the left, the graph falls. So we have two different notations to write that. In one notation, we're using the infinity symbol, where in words we're saying rises, or the negative infinity for falls. Okay, let's look at our next graph. So let's jump back over to Desmos. Clear that out. X to the fourth plus 2x to the third minus x minus 2. All right, so essentially we have this kind of W-shaped graph. Let's come back over here and do a quick sketch of that. And as I'm going through this video, I'm assuming you're writing it down in your workbook as well. Okay. So this first notation says on the right, or as x approaches infinity. So if we go to the right end of the graph, the far right end of the graph, so this is the right end of the graph over here, this graph is rising on the right-hand side, rising. So we say on the right, the graph rises. Oh, that's got a little shaky there. And for our notation, we use infinity, rises towards infinity. On the left, so here we go, following the graph to the left. And this one rises on the left as well. So on the left, the graph also rises. So on the left, the graph rises. And so we use infinity again. Okay, So now we've seen an example where it's rising on the right, falling on the left. It's rising on both the right and the left. Let's take a look at this one. Let's go to our Desmos. Okay, so in Desmos this time we have a negative x to the third. No, not what we wanted there. Plus 2x squared plus 2x minus 3. Okay. Negative x to the third plus 2x squared plus 2x minus 3. Okay, this is also a cubic function. It's kind of backwards from the first one we did, and that's because of that negative sign out front. So let's get a quick sketch of that going. And again, doesn't need to be perfect because we're really just concerned about what's going on the far ends here. Okay, so we've got the far right end and the far left end. Okay, so our notation. And on the test, you can actually use either notation. So we have x approaches infinity, or you can say on the right, y, and then the graph. All right, so we got to figure out what's going on the right. On the right-hand side, as I go to the far right side of the graph, we're falling. This time the graph falls. The graph falls. Okay. For our notation, we would say negative infinity. And now we have as x approaches negative infinity, which is our way of saying on the left. Y does something in the graph. Okay, so there's our two different notations. So let's grab our little shading and move to the left. So on the far left, this time the graph's rising on the far left. The graph rises. And we would say infinity. Okay, so there's 3 solid examples. Go back and watch any one of them again if you need to. We're going to go through the examples on page A16. I would encourage you to try number 4 on your own. So go ahead and enter number 4 into a calculator, into Desmos or a graphing calculator, pause my video, try it on your own, then watch my video and see if it matches. Okay, so hopefully you have tried this one on your own. If not, that's okay. We'll go through it together. So we have negative 2x squared plus 2, and then 5x squared minus 1. 5x squared minus 1. Okay, so now we have this kind of M-shaped graph. Let's go back and sketch that. Something like that. Our notation, so we have x approaches infinity, and x approaches negative infinity, y approaches, right? And this is our way of saying on the right, the graph, I don't like the way that H turned out. Let's try that again. The graph, and on the left, the graph. And you don't need to use both of these, honestly. I just want you to know both of them, or I want you to see both of them. Okay. So let's grab our little circle here. So on the right, this would be this on this end right here, but perhaps you're noticing right now that it falls on both sides. So we don't need to go through the whole rigmarole, whole song and dance. This falls on both sides. So the graph falls on both the left and the right. And so we would use negative infinity for both of those. Okay, we have 1, 2, 3 more. All right, this next graph, let's punch it into Desmos. And you're welcome to try this one on your own. I think that would be a good idea before we get started. 2 times 3 to the x minus 4. And then minus 3. Okay, so here is our graph. So let's go back and draw that. Okay, something like that. Set up our end behavior notation. On the right, the graph, and then the left. Remember, we say these as x approaches infinity, y does something. As x approaches negative infinity, y does something. But it's another way of saying on the left and on the right. Okay, so let's start with on the right. Let's grab our little circle here. So as I move to the right, on the right, over here, this graph is rising. So the graph rises. And we say infinity. Now, this is now the first time as we look to the left, this is the first time we've seen one not rise or fall. This graph doesn't rise to infinity and does not fall to negative infinity. This graph flattens out. It levels out. So then we would want you to say the graph approaches, oh boy, let's try that again. And then we're going to say -3, and we would put -3 here. Those are a little bit trickier, right? And to be honest, I'm more concerned that you can do the infinity ones, but I did want you to see a couple examples that they don't always rise or fall. Sometimes they do level off. So we say the graph approaches or levels off at -3. So the graph approaches -3. Okay, let's take a look at number 6. Go ahead and put that into Desmos. Here's your square root button down at the bottom. We have x plus 3. Arrow out of that, plus 2. Okay, so here is your graph. Go back and draw that. Something like that. Okay, so as x approaches infinity, y approaches. On the right, the graph. Okay, now I'm actually not going to write another part. I'm not going to write anything about the left, and we'll talk about that in a second. So on the right, this graph looks like it's kind of leveling off, but it actually will slowly continue to rise. So this graph rises, and it approaches infinity. And that's it. I'm not doing a left-hand side because this graph actually doesn't have an end behavior on the left. There's nothing over here. So it doesn't approach negative infinity. It stops right here. This is a starting point, stopping point. There's nothing over here, so we don't have an end behavior here. Okay, so let's go on to number 7. Okay, let's get that punched into our graphing calculator. Okay, so we have 3 over x minus 2 minus 3. All right, so here we are, 3 over x minus 2 minus 3. Okay, so this graph's in 2 parts. It's our rational graph. Let's go look at that one more time. Okay. Oh, whoops. Need a pencil here. Okay, so as x approaches infinity, what does y do? Or on the right, the graph, okay? And then our next notation is on as x approaches negative infinity, what does y do? Or on the left, the graph. Okay, we have both of those. All right, get our circle. So on the right, this tends to be where I see students go to, but that's not the far right. This is our far right. This is actually following the right over here. So this graph is actually leveling off. This graph levels off at -3. Graph approaches -3, and we put it up there as y approaches as well. And then on the left, here we are, and it's actually that same height. So same -3 approaches, -3. Okay, So that's the end of our end behavior video. The next video is going to deal with pages A17 and A18.